Hello. If you're a building owner in a sunny but stormy place like Florida, how do you make sure that when you have damage caused to a building by a storm, you're able to prove that that damage was actually caused by the storm and wasn't a pre-existing condition? Or if you've got to do milestone inspections or other regulatory inspections on your building, how do you make sure you do them in a cost-effective, complete, and efficient manner? Well, enter the world of drones. Drones have now arrived at the scene and they can now be used to essentially capture very comprehensive data and document any existing conditions on the building. And so therefore, in this video, what we're going to do is we're going to walk you through how you can actually plan an end-to-end process with drones and software, and also use things like AI to automatically find damage to a building and document all the conditions into a comprehensive report that you can use for any kind of insurance claim or application in the future. Let's have a look. Hey everyone, my name is Varun Sarwal from Hammer Missions, and in this particular video, what we're going to do is we're going to walk you through how a particular building in Florida was actually inspected using drones and AI. We're going to walk you through the entire process, going from flight planning to 3D modeling to AI-based analysis and finally reporting. So if you want to understand the whole process, do give this video a complete watch. Let's have a look. Right, so we're going to be using Hammer Missions for this project. So that's essentially a software AI platform that's going to help us with everything from flight planning to the AI analysis. So let's kick things off. So the building in question is this particular condo that you see on the screen at the moment. This particular condominium is essentially based in Florida, as you can probably tell from the coastline, which is right here visible on the screen. And so in this particular project, essentially all the different facades and the roof were captured using drones. And we're going to show you what that looks like towards the end of the video. To make this video concise, what we're going to do is actually going to focus on one of the particular facades. So if you look at this particular facade, the one that's sort of protruding from the building and the one that follows through are the ones that we're going to be inspecting today. Now, you can already see the issue with imagery from Google Earth. It's not detailed enough. It doesn't show the accurate conditions. And so therefore, this is where you need to really bring in drones. So the first step in our process is going to be going to Hammer Missions and planning our facade inspection. To do that, we're going to essentially go and center our map onto the building location. So that's quite straightforward. I've already created a mission file or a flight plan over here. And what I'm going to do is I'm going to go into our facade mapping tool. So I'm going to go pick the facade mapping tool. It also has a little bit of information included over here, if that's of interest. But basically, I'm just going to click on the facade mapping tool, and I'm going to draw a line to indicate the facades I'm interested in. So in this particular one, I'm interested in the facade essentially going into the building over here, and so I'm going to trace out that boundary. So I'm only looking at these facades over here. Arguably there's two different facades over here, and they're sort of jointed at the hip with this little crevice over here. So what we're going to do is we're going to draw a flight path of this nature. So essentially draw out the boundary or the polyline that traces that particular building. Once I've got that, I'm going to press OK, and it's going to generate a default flight plan for me. So after I've got a default flight plan, I can start tweaking the flight plan to essentially make that more, much more precise and essentially fit the building better. So if I'm essentially starting out with a metric unit, and if I want to change that to imperial, I can just do that over here. And I've got imperial units to now work with. So the first thing you'll do is to essentially look at the facade, and you will try to sort of understand, well, what are we going to be capturing along this boundary? And so what we've generated over here, these blue points are essentially indicating a facade mapping mission, which is looking into the building and essentially flying from left to right. So all of these blue points is where the drone would fly and take a photo. We'll see what that looks like in a second, but essentially we will be configuring this facade inspection mission and getting to a mission that we can actually fly. So what I've done is I've clicked on this gear over here, this little cog, and once I've got the gear icon open, I can essentially now set up all of the mission settings. So the first thing I've got to set up is the camera type, And so that's sort of asking me, well, what drone am I flying this with? And so this mission was actually conducted using a Mini 4 Pro. So we're going to choose a Mini 4 Pro camera. That's going to give me my GSD at this particular distance from the facade. And I'm going to come to GSD in a second, and I've covered this quite a few times in different videos, but GSD is really important when it comes to knowing the accurate resolution of the data you'll be taking in. We can choose whether we want to fly width first or height first. And so essentially that's essentially if you want to fly along the facade first and then up and down, or we want to fly up and down as we go along. And so there are different options for that and different scenarios where you might use one or the other. And so for the moment, we're going to leave this at width first. The height of the building or top altitude is the next parameter we need to set up. So by default, it's set to 164 feet or 160 feet. What we really want to do is we want to use the height of the building and put that parameter over here. This is where Google Earth comes in, because we will essentially be using, let's say, a rough parameter or a rough idea on where that particular, on how tall that building is, and we can fine tune that once we go to sites. So to get a rough idea for how big that building is, you can essentially use Google Earth. Now, it would be amazing if Google Earth supported height measurements, but it actually doesn't. So one of the tricks I like to use to try and estimate the height of the building is to take the building and to imagine a cube in that building. For example, over here in our particular example, I can see that this particular block of the building forms some form of a cube where I know this height is roughly the same height represented in this particular plane of the roof of the building. So what I can do is actually, as opposed to measuring the height, I can measure the roof along the same direction and get an estimate for the height. So let's say if I'm measuring the roof and I'm interested in what is the total height of the building around here, I could actually estimate that by looking at a cube and using that cube as my go-to. So once again, I'm going to stop measuring over here, go back down here. I can see that this height is represented probably along this particular section here. So this whole section is probably accurate when it comes to having the same height as the length. So I'm going to measure from here to there and use that as my measurement. So let's go and measure this. So let's add our first point over here. Let's add a second point over here. Okay, so Google's given me an indication, and that's about 40 meters. So I can reasonably estimate the building's about 40 meters in height or 120 feet. So I go back here and I change my altitude to 125 feet. We'd want to start from slightly higher than the building. So at the moment, Hammer's giving me an error because my bottom altitude isn't actually set. So let's say we want to go all the way down to 10 feet. And let's say we want to go to 125 feet. So we're starting at the top of the building and we're going all the way down to 10 feet. And essentially that allows us to capture. Now, we don't really have to go to 10 feet. We can actually go to something like 20 or 30 feet and use the gimbal angle to actually cover the last leg of the building. But for this particular example, I'm going to keep it to 20 feet, and that particular tip of using the gimbal angle is something I'm going to come to later on in the video. So gimbal angle, so at the moment it's set to 0 degrees, so we're looking straight ahead, and we want to keep that because we want to make sure that when we're using those inspection shots, we've got crystal clear data and we can actually use that for our facade mapping. So we'll keep that as we would want. And then horizontal distance, we would want to make that slightly closer. So at the moment it's 50 feet. We'll make that 30 feet. So essentially 30 feet or about 10 meters from the building, and that's fine. Overlap, we're going to crank that up to 75%. Minimum 75% overlap between images is a good idea. If you can get more because of the flight estimates, then go for it. So essentially what you'll find is that there's a particular correlation between how many batteries you use and what kind of flight profile you would have based on the overlaps. The more the overlap, the more the time it takes to capture that data. For example, if I crank this all the way up to 90, you'll notice that we've now got, 800 images, 6 batteries, and 115 minutes. Now that becomes unsustainable because we will also want to get this done. We don't want to be there all day. So 75% is acceptable, and that's what we're going to go with. Flight speed is automatically calculated by Hammer, so you don't really have to touch that. And some of these parameters here are helpful in case the flight mission was generated on the wrong side of the polyline. You can always turn it around, or if you were capturing the inside of the building, you can essentially turn around those points and then essentially fly to capture the insides. Also, as I mentioned earlier, if you wanted to take more than one image at every point, you can essentially turn on this option. And what this will do is that it would allow Hammer to take photos of the building as it goes around, and to take multiple gimbal angles, looking up, looking forward, and looking down for the building. This is quite an advanced option, so we would recommend starting off without using this option, because it's important, if this option is deployed, that later on the images are segregated and processed separately to get better results. So that's all on the flight planning side of things, and we've got our flight plan ready to go. This is all saved in Hammer Missions in the cloud, so I can always go back to it. So the next step would be to sync this up with the Android application that runs on the smart controller for the DJI drone used on this project. And so what we're going to do is we're going to turn over to Max from Engineering Essentials, who's going to be flying this project today. Well, that was some really interesting flying and some history there on the building for you by Max from Engineering Essentials. So thank you, Max, for flying the building and capturing all the data. And so what we're going to be doing is we're going to be essentially now looking at how do we upload, process, analyze, and share all of this data. So what we've got here, all of these yellow points that you notice on the screen. So we've got the same Google Map view, but what you'll notice is now we're in the data analysis view of Hammer as opposed to mission planning. And in the data analysis view, we're going to be actually looking at how do we inspect this building. So all of the images from the building have been uploaded to Hammer. You can see them over here in the bottom of the screen. So each one of these photos is actually a photo taken by Max for this particular project. And if I click on any one of these photos, it will show up on the right hand side over here in full resolution, so I can always go in and zoom. And this is where you can really see the power of drones. You can sort of see that you get all this detail that is just not available from satellite data, and having that data is what gives you the ability to then conduct the inspection to truly understand what are the existing conditions. And if you had to do this without drones, it would just be a very laborious, time-consuming process where you would have to get scaffolding up on the building, really expensive, and you may not be able to cover the entire facade of the building. So drones here make perfect sense. Now, back to our workflow. You've got essentially all of these images that have been captured by the drone, and they have been uploaded. We can also see them over here in the mini-map view, and all of these yellow points are essentially points where an image was taken. So I can click on any one of these points, and it would essentially bring up the image, and we will be able to see it with reference to the building on Google Maps. And as you can tell, we're looking from this point straight into the building, but we will notice that actually this point isn't quite aligned with where the building is, and it's actually showing us somewhat of what we would want to see, but not exactly the right orientation. And this is where what we need to do next is we need to process all of this data into a 2D map and a 3D model. So we'll go into our process images option over here, and then we're going to choose 2D map and 3D model. We're going to leave the advanced options as it is, but if you were processing thermal data, or if you wanted to clean up the model automatically, you have some of these options available to you. So, but in the default, most run-of-the-mill missions, you're going to be selecting 2D map and 3D model, and you're going to hit the process button. So you hit that button, and essentially the software will churn away in the background, and it will generate a 2D map and a 3D model of the particular building. So what we're going to do now is we're going to wait till the data is being processed, and we're going to come back and we're going to show you what that looks like. Okay, so we have our data processed, and so what we've got on the screen is essentially a stitched 3D model of the particular facade that was captured by Max on site. So what I'm doing here is I'm essentially moving around a 3D model that was created from the images that we saw earlier. And this was a completely automated process. Hammer Missions automatically takes all of the data and creates this 3D model for you. So you don't have to actually go there, sit there and model this building. You just have to press a button and it's done for you. And now what you'll notice is that you've got a lot more detail, and you've got all the images put together into a format where you can easily review all of the images without having to go through every single image one by one, at least for the larger defects and deficiencies or larger existing conditions. You can very quickly and easily document them. So to make this process really easy, what we're going to do is we're going to use a facade mode. So we're going to click on the facade mode over here. And what that does is that it essentially locks the 3D model into its position, so it doesn't really move in any other orientation apart from up, down, left, and right. So essentially, we made a 3D model somewhat 2D, although arguably 2.5D, because we can also see some of these. We can still see some of these interior facades and crevices, which you wouldn't normally be able to if it was just a 2D map. So let's have a look at the data. So what you would do now is, if you were inspecting this building as an engineer or an architect or a qualified exterior wall inspector, you can essentially go through all of the data by just going through the 3D model and looking at it as you go through the data. So you're almost looking at the data as if you were flying this building like a drone, and you would pick out any kind of defect or deficiency. So if there's anything that jumps out at you, you're able to actually use that for your analysis. And look at the amount of detail you can actually get. You can even see the condition of the stucco in this particular project. And based on the condition of the stucco, you can actually make a determination whether or not you've got old stucco patches or a stucco patch that is essentially deteriorating and needs to be marked up as an existing condition. You will also notice that actually sometimes it's really helpful to have not just the map or the model, but to be able to also go to the images themselves. So you will notice that some of the reconstructed 3D model over here is not as high quality as it could be, and that's predominantly because windows and reflective surfaces typically don't model very well when it comes to photogrammetry. So for some of those things, what you can do is you can actually just double click on the particular point of interest, and Hammer will automatically bring the right map or model or the right image into view for you, so that you can actually then have a look at that independent of it being a model. So what we've got here now is actually the same 2D point that we clicked on, but now it's available to us in image format, and we don't have that same reconstruction defect that we could see in the 3D model. And so the same point, if I was to sort of move this back, get out of my facade mode, move this back and zoom out, and we're looking at this particular window over here, and we were able to actually see that it's the same window that can be seen on the images as well. Obviously the images bring a lot more detail as opposed to the 2D map or the 3D model. Now, what you're able to do is you're able to actually go through all of the facade and mark up all of the existing conditions. So in this project, the same thing was done. And if I was to show you what that looks like, let's have a look at some of these defects. So I'm going to click on some of these defects. So if I click on one of these photos, you'll notice that actually some of these issues like damaged stucco paint has been marked up by the engineer on the project. And so this was actually Max. So Max has gone through the data and essentially looked at all of the different issues. So again, we've got damaged stucco paint, and there might be damaged stucco paint in many different images. And you might have other issues as well. For example, you might have old stucco patches that are forming, and you might have all kinds of issues that have been picked up. So we can essentially look at other images and it will show us all the different issues over here. Again, this is an old stucco patch and this is a damaged stucco paint example again. So you can essentially see all the different points or different places in the project where a particular existing condition has been documented. And this is where the power of drone data really comes into place, because you're able to actually use that to essentially make an assessment as to whether or not that condition was pre-existing. And you can use that for a conversation with perhaps the insurers, or you can have a conversation with other stakeholders, maybe the contractors, to explain what needs to be repaired and where. And all of that data has been existing. All of that data and existing conditions have been mapped and documented. And so you can essentially, with this process, mark up all of the different places where you have issues on the building. And what you can also do is you can actually get AI to automatically find issues for you as well. So the way it works is that you're able to actually use the defects created by an engineer to train AI models and to essentially use AI on the project and essentially find all sorts of different issues, whether it's cracks, whether it's missing paints, whether it's corrosion, whether it's brick cracks, or if it's something else. You can essentially use an AI model to automatically find all of the different defects and all the different or water ponding issues or spalls, all kinds of defects and deficiencies on a building. So we made a whole video on AI, so if you want to understand how that works, go watch that video next. We highly recommend it. But basically, you're able to find all the different issues with AI. And once you've gone through and done that process, what you're able to do is you're able to actually see all of that data on your Stitch 2D map itself. So if I click on the quantification feature over here, what Hammer will do is it will show me all of the different areas on the facade where a particular condition has been found, and those particular conditions are now quantified. So it's no good just finding the issues. You want to also quantify, well, how big is the damage? And so, for example, over here, there has been 23 observations that have been found, and we can see, well, there are 3 instances of stucco paint that have been damaged, and we can see that that sort of takes up 0.5 square meters of area. So if we need to change that stucco paint, well, you know, that's the amount of area we're looking at repairing. If you've got an issue with window frame coating, or if you've got an issue with dented shutter box, how much area does that actually take? And we've got, for example, the roll down shutter coating over here, which is essentially, there's about 10 observations of that, and that's taking up a huge percentage of the area. And so what you're able to also do is you're able to actually dig into, well, this particular existing condition, this particular deficiency, 169, well, what does that relate to? So we just double click on that and we were able to get to that particular existing condition, which is an old stucco patch. So I can zoom in and I can see what that existing condition looks like. And I can also see its location on the facade in case that needs to be communicated easily to the contractors fixing this facade on the stucco job. You can also very quickly and easily get to other parts of the building. So you can look at, for example, all stucco patches over here, just by the window, as you can tell. And you can also look at all sorts of other deficiencies that have been marked up, to look at the window frame quoting, and also to look at the window frame coating over there as well. So essentially, whether it's stucco patches, whether it's window frame, whether it's other forms of coating that needs to be repaired, you can clearly see you've got some coating issues over here on the window frame. All of these have now been are now existing conditions that have been documented, and you can essentially make a case for that to be present before the storm, and any conditions that have not been, any conditions that are not noted here in this data set, you can essentially make a point that that was essentially caused by either wind damage or hail damage or hurricane damage, and all of those can then be very communicated very easily and effectively to an insurer or to a stakeholder, board member, whoever needs to have that data to essentially decide the future of the building. So all that data is available, and the best way to actually share and present that data is, of course, you've got the luxury of the 3D model with all the defects labeled over here. But what you can also do is you can actually share the data with other people. So you can essentially bring in other stakeholders. So you can sort of bring in any stakeholder by adding their email address, or you can also create a project link directly from here, which is a private link that you can share with other stakeholders. And if you've got someone particularly interested in seeing a report, you can also create a report directly from the project. You can choose whether you want to add all the annotated images, whether you want to show only the unique deficiencies. You can make that judgment, and you can choose to have an introductory paragraph. For example, over here, we've documented that this was a particular inspection that was done and the purpose of the inspection and the key outcomes. You can add a cover image, you can add your brand, and you can add a footer which has all of the summary paragraphs and your company details. And you can also add your links from the report to the particular project that we're looking at. And if you really want to change things around and customize to the core, you can actually export everything into a Microsoft Word document. And in that document, you can make changes as you would in a normal Word file. And just to give you a sense for what that looks like, once you export the reports, you get essentially this particular report out of it. So you have essentially the name of the project, you've got the date and time when it was created, you have your cover image that you've added for the particular project, and you've got an introductory paragraph that has been added by the engineer in terms of what was done in this particular project. Say this was a drone-based inspection, and this was to visually document all the existing conditions before any kind of storm or hurricane was to cause any further damage. You have the location of the building, you have the date when this particular project was captured, and you've got the total images that were taken. And then finally, you have a particular deficiency quantification table that shows you all the different types of deficiencies, the total area they take on, the window frame coating, the old stucco patch, all of those different deficiencies, the different observations, and how much area they're taking up. And you can also see the actual details of the different conditions. So for example, if you wanted to see a particular damaged stucco paint, you can essentially just click on that, and then Hammer Missions will take you to that photograph that shows that particular condition in the overview, but also shows you the actual detailed condition when you zoom in. And you can do this for all sorts of different damages on the building, everything from an old stucco patch to damaged paint. And all of that can be then very quickly and easily seen by scrolling through the reports, and over here, just going through all of these different reports, all of these different numbered annotations. And one of the things I can also do is, if I was looking at this report as a stakeholder, I can just click on that particular image. If I'm looking at this particular image and I've got some sense on what this looks like. Let's say I'm looking at this particular annotation number 13, which is this damaged paint, and I really want to understand what the condition looks like. I can just click on this button, which is to open the project in 3D Web View. And what that does is that it essentially allows me to see the project without logging into Hammer Missions. I can see the project, and in fact, I can see the exact image where that particular deficiency was noted. And I can zoom in and I can really see any comments or conditions that were observed at that particular point on the building. So, and I've also got the luxury of the 3D model in case I wanted to see the entire full context of the building and really go into it and dig deeper. So there you have it, folks. We've got an end-to-end facade inspection that was performed on this particular building using drones and AI. We are very, very excited to share that these projects are now becoming increasingly viable, and that essentially paves the way for a more cost-effective and more comprehensive inspection using drones. We think that technology essentially is something that brings a lot of value to many industries, and we think that keeping our buildings safe and compliant is something where drones can add a ton of value. So if you have any questions on this process, on how this was done, and would like to chip in terms of your experiences of using drones for condo inspections or facade inspections or generally any kind of inspection, do chip in the comments below. If you have any particular things that you think we should cover in our next videos, let us know. But thanks so much for watching, and we'll see you in the next video for Hammer Missions.